3rd February 2026 और यूनिट नंबर 2 में we are going to start wave section and it is our first class. In first class we are going to start wave properties और wave properties में आप IGCSE में you have already studied कि if you are given this wave अच्छा मैंने वेव को प्रॉपरली पढ़ाना चाहिए क्योंकि ओनली मनाहिल जो है ये प्राइवेट स्टूडेंट है बाकी सारे रेगुलर स्टूडेंट है तो मुझे पहले वेव प्रॉपरली पढ़ाना चाहिए रुक जाइए पहले वेव बेटा मैं प्रॉपरली पढ़ा रहा हूँ फिर मैं उधर आपको लेके जा रहा हूँ जरा सुनिएगा प्रॉपरली पढ़ाने में बेटा ये है कि कंसीडर दिस इज अ मेटल बॉब सस्पेंडेड वर्टिकली एंड दिस पोजीशन of the metal bob it is called mean position or equilibrium position. Acha, if I displace this object towards one side, then this is called extreme position. And the separation between mean position to extreme position. The separation between mean position to extreme position. This separation is called amplitude. This separation is called amplitude. And amplitude is the maximum displacement. Sir, what is the meaning of displacement? This is not a displacement of kinematics. It is not that displacement. Displacement means when an object making vibratory motion, then you can see the position of the object is keep on changing. If you are starting from position number 1 and consider this is the mean position, then the position number 1 to mean position, it is called amplitude. But when the bob will be at position number 2, it will be at position number 3, it will be at position number 4, then obviously the position of the bob is keep on changing and its distance from mean position is changing. So the distance between any point or any instantaneous point to mean point, this distance is called displacement. Displacement is not kinematics displacement. Displacement is a term in oscillatory motion. The maximum displacement, it is called amplitude. And this now displacement is decreasing from position 2, from position 3, from position 4, from position 5, and from position 6. You can see displacement is keep on changing. Displacement is a quantity which keep on changing, whereas amplitude is a fixed quantity. Sir, why? Because amplitude is the maximum displacement, whereas normal displacement keep on changing. And if an object is at mean position, if an object is at mean position, then its displacement is zero. So when displacement is zero, it means the object is at mean position. But when the object is moving away from the mean position, now the object is moving away from the mean position, then obviously its displacement is increasing. Displacement is increasing. Displacement is increasing. But when an object moves towards mean position, sorry, towards extreme position, its velocity is decreasing. And if its velocity is decreasing, then you can see the gradient of displacement time graph is decreasing. If the graph bending horizontally, it means the gradient is decreasing. Decreasing gradient means, sir, velocity is decreasing. So from mean position to extreme position, this is the graph. And when the object return to the mean position, then again displacement begins to decrease. Displacement begins to decrease, but velocity is increasing. When object moving towards mean position, then velocity is increasing. And remember, at mean position, velocity will be maximum. And now the bob is moving on the other direction. And you know when the direction reversed, now it is moving towards right hand side. So the displacement graph will below the x-axis. And again, when it reaches at the extreme position, then velocity will be zero. And when it returns back, then velocity keep on increasing. So I can say when an object making oscillatory motion, then this is displacement time graph. And in this displacement time graph, this is mean position displacement. This is extreme position displacement. Again mean position. Again extreme position. And now it has completed one complete cycle. And when any object makes one oscillation, then you know the time to make one complete oscillation, it is called time period. So the time of one cycle, the time of one oscillation, this time is called time period. And in this graph, this is a graph of oscillatory object in which displacement is along y-axis and time is along x-axis. And the graph which I have drawn, this is graph of one complete oscillation. So I am repeating, sir, what is amplitude? By amplitude is the maximum displacement. Sir, what is amplitude? Amplitude is maximum displacement. So this vertical line represents amplitude. This vertical line represents amplitude. But sir, this vertical black line is displacement. This is displacement. This is displacement. This is displacement. So displacement may be zero. Displacement may decrease. The value of displacement may be equal to zero. When the object is at mean position, then its displacement is zero. And when the object is at extreme position, then its displacement is called amplitude. When the object is moving in the other direction, then again you can see amplitude is increasing, sorry, displacement is increasing. This is maximum amplitude, and now amplitude is decreasing. And when the object returns to its mean position, returns to its mean position, then displacement becomes zero. So this is graph, and graph you should know very well because in your paper you will be given a graph and then they will ask question. So you must know graph. Okay. So Abdullah, can I ask a question? Abdullah, Abdullah, beta, what is amplitude? Okay, you can say sir, amplitude is maximum displacement, and this displacement is measured from mean position, not origin, beta, from mean position to extreme position. Okay, so the distance or maximum displacement from mean position to extreme position, it is called amplitude. Okay, and what about time period? So time period is the time to complete one oscillation. The time to complete one oscillation. In this graph, time is along x-axis. So when one cycle is completed, then the time of one complete cycle, it is called time period. So when in graph you are given time, the length of one cycle, it is called time period. But sometime, sometime you will be given graph displacement versus distance. displacement versus distance. Or this graph, you can assume, you can assume this green line is a string. Consider this green line is a string, and this string is in your hand. And when you move your hand up and down, then this kind of wave is produced. And now you can see the wave is traveling from left to right. So this wave is covering distance as the wave moving forward. Consider this is a string, this is a rope, and you are moving your hand up and down. Then obviously you are producing wave in the string, and you can see the wave is traveling. Sir, when wave is traveling towards right hand side, wave is traveling towards right hand side, then you can see, sir, this particle, these particles are string particle, and you can see this particle is moving upward, this particle is moving downward, this particle moving upward, this particle moving downward. So these particles are moving up and down. Right now, their positions are shown by these arrows, but later on, this particle will move down. This particle will move up. This particle move down. This particle move up. It means, sir, when wave passes through a medium, note down this sentence. When wave, wave means energy. When energy passes through a medium, then particles start vibration. Particles are vibrating. As I said, this particle later on will move downward. So I can say this particle will keep on moving up and down, up and down. Particles are moving up and down. Okay, so when a wave or energy passes through a medium, particles start vibration. And by this vibration, energy is traveling from one point to the other point. You can see, sir, the kinetic energy of my hand. My hand is moving up and down, and the kinetic energy of my hand enters into the string, and now string moving forward. But actually, string is not moving forward. The particles of medium, the particles of string, just vibrating. String does not move forward. Actually, energy is moving. Actually, energy is propagating. Energy is moving, particle just moving up and down. Particle moving just up and down. And remember, there are two types of waves. Number one, transverse wave. Number two, longitudinal waves. Today we will not discuss longitudinal. Today we are dealing only transverse wave. And in transverse waves, sir, particles vibrate perpendicular on wave motion. You can see in this graph, you can see in this graph, so the wave is traveling towards right hand side and particle moving perpendicular on it. Particle moving perpendicular or vertical on the horizontal motion of the wave. So when energy passes through a medium, just like in a string, particles are vibrating. And if particle vibrating perpendicularly, then this is called transverse wave. But right now we are not dealing longitudinal wave. Acha, in this transverse wave, everyone knows, sir, this portion of the wave is called crest. This portion of the wave is called crest, whereas this portion of the wave is called trough. So we can say, sir, transverse wave composed of crest and trough. And if along x-axis you are given distance, Then remember, then remember, crest to crest distance, crest to crest distance, it is called one wavelength. Or trough to trough distance is called one wavelength. Or the most better definition, I think, is, sir, if we measure the length of one cycle, you can see, sir, this is one complete cycle. You can see this is one complete cycle. This is one complete cycle. In this complete cycle, upward motion, downward motion. The length of one complete cycle, sir, it is called one wavelength. So I have stated three definitions. Number one, sir, distance between crest to crest, the distance between trough to trough, or the best definition is the length of one cycle. The length of one cycle, it is called one wavelength. So remember, if along x-axis there is a distance, if along x-axis there is a distance, then this is wavelength. And if along x-axis there is a time, then the length of one cycle, it is called time period. So whenever I show you a graph, then you should check which physical quantity is along x-axis. If time is along x-axis, then there will be time period. And if distance is along x-axis, then it will give you wavelength. And now, these are basic definition, which I have explained you on the blank page. Amplitude, we have discussed. It is the maximum displacement from mean position. Time period, the time for one oscillation. Time for one oscillation. Wavelength, the length of one oscillation, or the distance between crest to crest or trough to trough. Speed, distance per unit time. Frequency, so sometime some object make very fast oscillation, just like guitar string vibrate very fast, etc. So number of oscillation in per second, number of oscillation in per second. It is called frequency, and frequency unit is hertz, and it is equal to 1 upon time period. So this formula we have already studied in IGCSE, so I'm not passing time in this basic definitions. Actually, this is the formula which we will use in this chapter as well. V is equal to F lambda. So then we have studied transverse wave. I'm not repeating. Sir, we have discussed this one. Okay, if there is distance is along x-axis, then this length is wavelength. If time is along x-axis, then this distance will be time period. Okay, and now by studying these basic definitions, now we can start past paper questions. The first question on your screen. So the first question of today's class is, sir, this is a graph. In this graph, along x-axis, so there is a time. There is a time. And by this graph, I can I can determine the time period of the wave. Yes. The reciprocal of time period will be frequency. Yes. This is the maximum displacement. It is called amplitude. Yes. So the question is, I can determine directly by this graph these three quantities. I can determine time period, I can determine frequency, I can determine amplitude, but I cannot determine wavelength by this graph. Sir, why? Because if I am interested to calculate wavelength, then here should not be time. If here is distance, then I can determine wavelength. But right now, along x-axis, sir, you are given time, and by time you can calculate time period, you can frequency, you can amplitude, which is the vertical distance, but you cannot determine the wavelength. So the right answer of this question is D. And the same question is repeated in June 2022 paper, same question. Which quantity we cannot determine. So the answer is wavelength. Okay, so we should not waste time. But now this question is, sir, you are given two graphs in this question, October 2020. You are given two graphs. The first one is displacement versus distance, and the other one displacement against time. This graph, distance, this graph versus time, along x-axis there is displacement. And you know displacement means the distance from mean position to any position. Okay. And now the question is, you have to use both graphs. You have to use both graphs. Then by using both graphs, which quantity we can determine? So the answer is, sir, speed of the wave is the product of frequency and wavelength. And you know frequency is the reciprocal of time period. So by distance graph, sir, you can calculate wavelength. By time graph, sir, you can calculate time period. And if you have to use both graph, then you can calculate speed of the wave. And before recording your class, we have discussed all these three questions with Zainab and Abdullah. That's why I did not ask you to solve these questions, because before recording, for time passing, we have discussed these three questions earlier. And now this is a question in which I would like to involve you. Simra beta, this is another question, January 2021. Along x-axis, sir, you are given time. Ji beta Simra, which physical quantity you can easily determine by this graph? Acha beta Simra, can you read what is the amplitude of the graph? Amplitude? Amplitude, I am asking amplitude beta. Yes, amplitude is 10. And the given option amplitude is 20. So this option is wrong. Okay. And now I am asking you, Simra, again, what is time period of this wave? What is time period of this wave? What is the length of the time for one complete oscillation? So this is the peak point. This is the peak point. So this is one oscillation. And the corresponding time for one oscillation is zero point 0.4. So this zero point 0.4 is the time period. Simra beta, this is one complete cycle from peak to peak. This is one time period, because along x-axis you are given time. If you are given distance, then it would be wavelength. But this is time. So this time is time period, and the option is time period is zero point 0.2 second. So it is also wrong. Time period is not zero point 0.2. Time period is zero point 0.4. And now I am going to calculate frequency. But Simra, can you calculate frequency? Because frequency is 1 upon time. And if the time is zero point 0.4, then if you calculate 1 upon zero point 0.4, then what is the answer? 2.5. So the frequency is 2.5. So the right answer is beta. The frequency of the wave is 2.5 hertz. So by all these three questions or four questions, I think I have cleared you this concept. Check which physical quantity is along x-axis. If time, then you can calculate time period. If it is distance, then you can calculate wavelength. And now this is another question from June 2021. But Baneem, can you help me to solve this question? Because question is very simple. You have to calculate the speed of the wave. And you know speed is equals to, I'm not interested to explain because question is very simple. Baneem beta. Banin beta, are you in class? You are saying D and you are right because speed is the product of frequency and wavelength. So frequency is 1 upon time. So speed is equals to wavelength upon time. So Banin answer is right and no amplitude is used to calculate the speed of the wave. Banin beta बेहतरीन. And now I will have to explain a new concept for the other question. Okay, but this is a very difficult concept which I am going to explain. So the concept is, consider this is a rope and this is supported and the other end is in my hand and now my hand is moving up and down. And when my hand moves up and down, then this kind of wave is produced. But this pattern will not be static. When wave is traveling through a medium, then the medium is not static. The medium is keep on vibrating. So if I say you, sir, this is the wave pattern at t is equal to 0 second. T is equal to 0 second means I have a stopwatch in my hand and now I am starting a stopwatch. So the time is 0 second, and when the time is 0 second, this is the pattern. And now I'm saying the time period of this wave is considered 4 millisecond. And now the question is, what will be pattern after after 1 millisecond? And this 1 millisecond actually it is t upon 4 time later. This is t upon 4 time later. Okay, sir, we are given a wave pattern and we have to draw another wave pattern after 1 millisecond. And what will be the pattern? I am going to explain with a rule. With a rule. Sir, what is the rule? The rule to explain this is consider, sir, this point is A, this point is B, C, D, E, F, G, H, I. ठीक है। अच्छा बेटा जैनब आप नोट कीजिएगा, मुझे लगता है आप स्कूल में पढ़ती है लेकिन मुझे नहीं लगता कि स्कूल की टीचर ने आपको ये वाला टॉपिक पढ़ाया होगा, और अगर पढ़ाया है तो क्या आप इसका आंसर कर सकती है कि इससे अगला आंसर क्या होगा इसका? बेटा जैनब, बनीन, सिमरा, ऑल ऑफ यू गो टू स्कूल, देन आई एम आस्किंग यू कि इस क्वेश्चन में क्या करना है, आप बता सकते हैं जैनब? आपको लग रहा है बी? अच्छा जी, बिल्कुल गलत आपका आंसर है। ठीक है, आप मुझे समझाने दें, मैं इसीलिए आपसे एक आइडिया लेना चाह रहा था। ठीक है, अब जरा सुनिएगा रूल क्या है। सर रूल ये है, और ये रूल नोट कर लीजिएगा। रूल बेटा लिखिएगा कि एवरी पार्टिकल ऑफ वेव ऑफ मीडियम फॉलोज preceding particle. Preceding means previous particle, last particle. So what does it mean? I'm explaining. Explanation is, if I ask you this particle C, this particle C, it there are two possibilities. Sir, C may move upward और सी मे मूव डाउनवर्ड। सी के पास बेटा दो चॉइसेस हैं, सी ऊपर भी जा सकता है, नीचे भी जा सकता है। ठीक है, लेकिन इफ आई आस्क यू अबाउट बी, सर बी इज एट एक्सट्रीम पोजीशन, सो देयर इज नो ऑप्शन फॉर बी आइदर टू मूव अप डाउनवर्ड। डाउनवर्ड के अलावा कहीं और जा ही नहीं सकता। बी हैज नो अदर ऑप्शन। ठीक है, सो आई एम नॉट टीचिंग यू अबाउट बी, आई एम टीचिंग अबाउट सी। सर दिस सी पार्टिकल मे मूव upward or move downward. So according to the rule, sir, particle follows the previous particle, and the previous particle of C is B. B is already upward, so particle C will move upward. Particle C will move upward. अच्छा जी, Zainab, particle E having two choices, either move upward or move downward. What is preceding particle of E? Zainab, what D? Which is downward. So E must move downward. E must move downward. अच्छा जी, in which direction G will move? Zainab, in which direction G will move upward because its preceding particle is F. Okay, beta. So every particle follows the movement of its preceding particle, and this rule is valid only for t upon 4 seconds later. T upon 4 means if the total time period is 4 milliseconds, then this rule which I am teaching you only valid for t upon 4. And now I am solving paper question. I am solving paper question. Manahil beta, can you help me? This particle X, it has two choices. It may move upward, it may move downward, and the wave is traveling towards right hand side. And I am giving you two options. Give me 1 minute. This particle is A, this particle is B, this particle is C. Actually, these are not option. I should not use A, B, C. I should use P, Q, R. These are random name I have given. मुझे सिर्फ मनाइल ये बताएं what is preceding particle of X? X का preceding particle क्या है? P है. तो X either move upward or downward. आपके ख्याल में X कहाँ जाएगा? Upward जाएगा. तो X ने upward जाना है. जना बेटा X ने upward जाना है. ठीक. अच्छा मनाहिल आप ही मुझे बताएंगी. Y. बताइएगा Y का preceding particle कौन सा है? Q. तो Q Y से ऊपर है नीचे? ऊपर है तो Y कहाँ जाएगा आफ्टर T अपॉन 4? अप अपवर्ड. ये ऊपर जाएगा. तो Y जाएगा अपवर्ड. अच्छा Y अपवर्ड जाएगा तो इसलिए इसका आंसर बनेगा डी. जैनब बेटा अब आपको ये कॉन्सेप्ट समझ में आ गया कि वेन. जी जी जी. लेकिन नहीं नहीं देखिए. राइट नाउ व्हाट इज द पोजीशन ऑफ क्यू विद रेस्पेक्ट टू वाई. Position of q with respect to y. So you can see, sir, the q is upward with respect to y. So in future, y will move upward. ठीक है बेटा. तो हर पार्टिकल अपने प्रीसीडिंग पार्टिकल को फॉलो करता है. इससे मुश्किल सवाल इससे अगला सवाल है. रुक जाए जैनब, इससे अगला सवाल और भी ज्यादा मुश्किल है. ठीक. उसमें क्या हो रहा है तो जरा सुने. जो रूल बेटा अभी मैंने आपको बताया ना, दिस रूल इज वैलिड फॉर टी अपॉन 4. ठीक. टी अपॉन 4. लेकिन जरा नोट कीजिएगा, if I ask you Zainab कि particle C after t upon 4 it will move upward and then further t upon 4, you know t upon 4 plus t upon 4, it becomes t upon 2. So if I ask you where will be point C after t upon 2, so your answer should be, sir, for first t upon 4 it will move upward, but there is no further space to move further upward. So obviously, sir, after t upon 4, it will return to C. Move upward and then return to C. अच्छा जी, जरा अगला सवाल आपसे करने जा रहा हूँ. जरा ये देखिएगा ये वाला क्वेश्चन. क्वेश्चन है, द वेव इज ट्रेवलिंग टुवर्ड्स राइट हैंड साइड. द वेव इज ट्रेवलिंग टुवर्ड्स राइट हैंड साइड. ओके. एंड द पार्टिकल L इज हियर. पार्टिकल L इज हियर. ठीक है जी. एंड इट्स प्रीसीडिंग पार्टिकल इज दिस. एज वेल एज एल हैज नो अदर चॉइस कि वो ऊपर जाए या नीचे. एल ने तो सर ऊपर ही जाना है. एल ने ऊपर ही जाना है. ठीक है ना. एल ने ऊपर ही जाना है. ठीक. लेकिन जब ये एल ऊपर जाएगा तो विल बी इट विल बी टी अपॉन 4. फिर सर ये और ऊपर जाएगा, तो इट मेक्स टोटल t अपॉन टू. सो इफ आई आस्क यू कि आफ्टर t अपॉन टू, सर कहाँ लिखा है t अपॉन टू, जरा रीड कीजिएगा क्वेश्चन. ड्यूरिंग नेक्स्ट हाफ साइकिल, during next half cycle, you know the half cycle of L, the half cycle of L, sir, it is quarter cycle, it is half cycle, then this is three quarter cycle, and then it is one cycle. So Zainab beta, I am asking you for next half cycle, what will be direction of motion of point L? Will it be keep on rising, rise then fall, rise then fall? Ji Zainab beta, what do you suggest for L for next half cycle? Rise then fall. Ya Allah. Zainab, you are wrong. For next half cycle. Sir, this is half cycle. This is one complete cycle. Just rise. Only rise. This is one complete cycle. है ना? बेटा ये बात तो समझ में आती है ना. वन साइकिल में क्या होना है? The object will return back to its original position. So L is moving upward. This is the half cycle, and then it returns back to complete one cycle. So only to make a half cycle, it will keep on rising. Only keep on rising. अच्छा जी, Simra, Simra, can you help me for point M? In which direction M will move, upward or downward? Upward. Totally wrong. The preceding particle of M is L. The preceding particle of M is L. But Simra, L is upward or downward with respect to M? हाँ बेटा, Simra, where is L? L is upward or downward? L is below or above than M? Below. And if L is below, then obviously every particle follows its preceding particle. So M will move first downward. Okay? It will move downward. First, it will move downward. It is not half cycle. It is not half cycle. It is quarter cycle. Then it will return to its original position. Then it will rise up, then fall down. So I am repeating again. Sir, M move first down. First it will move down and then up, then rise. And in this way, during half cycle, during half cycle, the M point would have returned back to its original position. It would have returned to its original position. हाँ बेटा सिमरा, is it clear or not? Okay. And if it is clear, although the question is completed, the answer is B. But I am asking you one more question. And this is my own question. The question is completed, and for practice, I am asking you. Consider this point is Q. Okay? I am asking you, where will it be Q after half cycle? Where will be point Q after half cycle? Simra, answer me. It will move upward or downward? Upward or downward? Q. Obviously, it has no place to move further upward. It is already at extreme position. Okay, beta. So it will move first downward and then further downward for completing half cycle. For completing half cycle. Okay. अच्छा बेटा सिमरा, for point R, where will it move? Upward or downward? Downward. Ya Allah. This is the preceding particle. of R. This is the preceding particle of R. Okay. And if it is preceding particle of R, then obviously R will move upward to follow Q. To follow Q. Q is above. Q is above. So R will move upward and then it will move downward. Acha, Disimra, I have asked you too many questions, but you could not reply me right. But now I am asking with Abdullah. Abdullah is a genius student, and I hope he will reply me perfect answer. But Abdullah, if I ask you this point, consider this point is P. Okay, in which direction P will move, upward or downward? Upward. Its preceding particle is here, so this P should move downward because the preceding particle of P is where? अब्दुल्ला P का प्रीवियस पार्टिकल कौन कहाँ है? R नीचे है या ऊपर है? डाउन. तो P will move first down. अच्छा चले, मैं क्वेश्चन बदल लेता हूँ. ये बताइए, M in which direction will it move? You know कि पार्टिकल ओनली मूव अप और डाउन. फॉरवर्ड बैकवर्ड कहाँ से आ गया भाई? You know the particle of the medium move either upward or downward. When a wave is traveling through a medium, particles do not move in forward direction. Particles just vibrate, remaining at their mean position. At mean position, they only vibrate. They do not move forward or backward. This is a transverse wave. ठीक है बेटा? Abdullah beta, where M will move upward or downward? Yes. Why it will go down? Why? Yes. L is the previous point, so it will move down. Okay, it will move down. But this is not complete cycle. Sir, this is quarter cycle. If I ask you about half cycle, half oscillation, where will M be after half oscillation? Abdullah, where point M will be after half oscillation? It moved down, then it will move up, and M would return to the same point. Okay, beta? So we have completed this concept. Is that every particle follows the movement of its previous particle. Every particle follows the movement of previous particle. So M will move down and then up, down and then up. But L, sir, L will move up and further up. So for L, it will move only upward for half cycle, whereas M will move first fall and then rise. So this question is completed. And now this is a question. This is a question. Acha ji, I am asking a difficult question with Zainab. Zainab beta, is it graph of transverse wave or longitudinal wave? Transverse. ठीक है, पर गौर से सुनिएगा. The shape of graph. If it is a graph, if it is a graph, it is not an original wave. If it is a graph, then this graph may be of transverse wave or it may be of longitudinal wave. And now read the wording. Sir, this is a sound wave. Okay? And everyone knows, sir, sound wave is longitudinal wave. Okay? And this longitudinal wave graph is just like transverse wave graph. ठीक है, तो ये बात भी काफी बच्चों को नहीं पता होती जैनब कि ट्रांसवर्स वेव और लॉन्गिट्यूडनल वेव दोनों का ग्राफ एक ही शक्ल का बनता है. ग्राफ, इट इज नॉट ओरिजिनल वेव. ठीक है जी. एक बात हो गई. सर ये वेव का ग्राफ कैसे बना ये भी मैं आपको समझाऊंगा. अलबत्ता अभी जरा मुझे एक आसान सा सवाल करने दें. क्वेश्चन में खुद कह रहे हैं कि इन दिस ग्राफ वी इज अ कॉम्प्रेशन. V is a compression. Everyone knows in longitudinal wave there is a compression and rarefaction. there is a compression and rarefaction. Okay, and wave, uh, this V is a compression. And now they are asking at which position there is also one compression. At which position there will also be a compression. Then obviously, sir, in longitudinal wave, compression to compression, there will be one complete cycle. So, but as Zainab, at which point one cycle is completing? At which point one cycle is completing? Yes. When you study Z, then obviously, sir, it is one complete cycle, upward and downward. So this is one complete cycle. And length of one complete cycle is one wavelength. And you know, wavelength is the separation between compression to compression or rarefaction to rarefaction. So I can say if V is first compression, then Z will be the other compression. If V is one compression, then Z will also be other compression. Because compression to compression, sir, it is one complete cycle. Compression to compression, it is one complete cycle. Okay. And now the question is, sir, how is it possible? The graph of longitudinal wave is like this. You can see what a longitudinal wave, and this is displacement distance graph. You are given displacement distance graph. And in this graph, they are asking, बताइए, where is compression and where is rarefaction? So in tomorrow class, I will explain you where is compression and where is rarefaction. But I think if I share you this video, the original video from the YouTube, this is a screen recording. Then if you watch this video before my tomorrow class, then I think you can understand the graph of longitudinal wave. अदरवाइज मुझे पूरी क्लास लग जाएगी आपको समझाने में कि लॉन्गिट्यूडिनल वेव का ग्राफ बनता कैसे। सही है जी।